Welcome to SleepTechWorld.com, the human heart made easy. Within this presentation, we will review heart chambers, how to read EKG signals, reading EKG strips and sinus rhythms, heart blocks, arrhythmias, irregular rhythms requiring emergency attention. The human heart. To understand how blood travels through the human body, we must begin at the heart. It's essential that the heart maintains a regular, rhythmic beat, producing a constant and maximum flow of blood to the tissues of the body. The heart is divided into 4 chambers. The upper chambers are called the left and the right atrium, and the lower chambers, which are called the left and the right ventricles. The chambers are divided by a thick wall called the spectrum. The function of the right atrium is to receive deoxygenated blood from the body. It then pumps the deoxygenated blood downward into the right ventricle chamber. Once the right ventricle receives this deoxygenated blood, its main job is to direct this blood to the pulmonary arteries, which guides the deoxygenated blood to the left and the right lungs to be reoxygenated. Once this oxygen-rich blood leaves the lungs, it re-enters the heart by way of the upper left atrium. This oxygen-rich blood is then pumped downward into the heart's left ventricle chamber. The main function of the left ventricle is to pump this new oxygenated blood back into the body. Locate the heart's valves. In the heart, there's 4 valves that direct blood flow. Blood goes through each valve before entering or leaving each heart's chamber. They open and shut as the heart depolarizes or contracts, and closes when the heart repolarizes or relaxes. In short, each valve works like a one-way door. Each valve job is to prevent blood from re-entering into the heart's chambers. For this reason, it's important for the technician to understand the location of each valve. First, deoxygenated blood is collected within the right atrium. It must exit through the tricuspid valve or door in order to enter into the right ventricle. Second, the blood exits the right ventricle via the pulmonary valve or door, which transmits this deoxygenated blood to the pulmonary arteries and lungs. Once the reoxygenated blood returns to the heart, it re-enters the heart via the left atrium. This blood then passes through the mitral valve in order to get to the left ventricle. The blood exits through the left ventricle via the aorta valve, which transmits the oxygen-rich blood back into the body. How to read an EKG signal. Proper electrode attachment and placement is essential in acquiring an accurate EKG signal. EKG leads record small voltage changes as potential differences, which is transmitted into a visual tracing. FYI, remember, do not place EKG leads over a patient's pacemaker or use expired EKG pads. This could cause a poor signal tracing or artifact. Step 1. Preparations. Use alcohol wipes to prep the area you wish to attach the electrodes to the patient's chest area. Step 2. Locate the right arm and chest area. Place your first pad about 2 fingers below your patient's right clavicle bone. Next, on the left side of your patient, locate the 5th intercostal space along the rib cage. This is where you will attach your second EKG pad. The nerve center of the heart. An electrical impulse is generated by the sinus node, or as we normally call it, the SA node. Its job is to act as the heart natural pacemaker. The SA node is a small mass of specialized tissue located in the right upper chamber of the heart's atrium. The SA node sparks an electrical current across both left and right atrium chambers, causing both atrium chambers to contract at the same time. This action is referred to as depolarization. Next, the electrical impulse travels from the sinus node to the atrioventricular node, or as we normally call it, the AV node. Once the pulse reaches the AV node, the signal slows down for a very short period. Then it continues down the conduction pathway to the bundle of His, located inside the ventricles. It's important to note the bundle of His divides into right and left pathways called bundle branches. Once the current splits into the right and the left bundle branch within the ventricles, the signal branches out into the Purkinje fibers. The Purkinje fibers carry the electrical impulse from both left and right bundle branches to the walls of the ventricle, causing the muscle tissue of the ventricles to contract. Once the electrical pulse discharge is complete, the heart then relaxes. This relaxation action is referred to as repolarization. EKG electrical generations. Have you ever wondered what causes the heart to beat? Your heart beats as a result of the generation and conduction of electrical impulses. When recording an EKG signal, we actually are monitoring small voltage changes as the electrical signals travels throughout the heart. The heart electrical pathway can be explained in 6 easy steps. First, the sino or SA node is the starting point of the heart's electrical generation. Because of this action, it's often referred to as the heart's automatic pacemaker. The electrical discharge within the SA node causes the P wave to appear. Step 2. When the atrial depolarization is complete, the impulse is then transferred to the AV node. Step 3. The ventricular depolarization begins at the axis, causing a QRS complex to appear. Step 4. The ventricular depolarization is complete. Step 5. Ventricular repolarization occurs at the axis, causing the T wave to appear. And finally, step 6. Ventricular repolarization is complete.